Section 6.6 talks about the law of cosine. Consider the following triangles. Assume you're given those angles and those sides. If I am to draw the height, the traditional, if I call this L, then this right here would be C minus L. Now if I take this triangle right here, I know that B squared equals H squared plus C minus L squared. I'll go on the side and I look at this triangle. From that triangle, I know that let me see, the sine of angle B is the opposite over the hypotenuse. So H is actually A, the sine of B. Also, the sine of angle A, or I should say the cosine of angle A, is the adjacent over the hypotenuse. So I could say that actually I'm going to go for the cosine of A. The cosine of B. The cosine of B is going to equal the adjacent over the hypotenuse. And if I cross multiply, I'll get L to equal A, the cosine of angle B. So if I fill in the blanks, B squared is fine. In place of H squared, I'm going to use A, the sine of angle beta, plus C minus, and instead of L, I'm going to use A, the cosine of beta, squared. And this would be B squared equals A squared, the sine squared of beta, plus C squared minus twice AC, the cosine of beta, plus A squared, the cosine squared of beta. B squared will equal, if I factor an A squared out of those, that's sine squared of beta plus cosine squared of beta, plus C squared minus 2AC, the cosine of beta. And I know that sine squared plus cosine squared is 1. So B squared equals A squared plus C squared minus 2AC, the cosine of beta. What this does, all of these sides and angles are given. What this is saying, if I go back to the original triangle, if you take a side and you square it, that would be the square of the other two sides, like Pythagorean theorem, except minus 2 times A times C times the cosine of the angle opposite of that side. And similarly, so I have B squared equals A squared plus C squared minus 2AC, the cosine of beta. If I picked side A and I squared it, that's B squared plus C squared, again, like Pythagorean theorem, minus 2 times the product of those two sides, times the cosine of the angle opposite of side A, and similarly C squared equal B squared plus A squared minus twice AB, the cosine of the angle opposite of C, and this is the famous law of cosine. So, if I look at my first example, you'll notice these problems are picked so that the law of sine doesn't work. It doesn't say how to solve. You can solve any way you want. Solve the following triangle. the law of sine doesn't work because I have an angle, but I don't have the opposite side of that angle. If I call this C, this is what I know. I know that C squared equals this side squared plus this side squared minus twice the product of the sides times the cosine of the angle opposite of this side, which is 100 degrees, and C will equal the square root of that answer. So I'm going to figure out what this is in a minute. So if I throw this in my calculator, I'll get 2612.2, and if I take the square root of both sides, I'll get side C to be simply 51.5. And now that I know this, I could use the law of sine or the law of cosine to figure out the rest. It doesn't matter. So if I want to use the law of sine in this case, now that I have this angle, I could say the sine of 100 degrees to 51.5 should equal the sine of beta, say, 37. And I know how this works. The sine of beta is going to be 37, the sine of 100 degrees over 51.5. And beta would be, and I know it's going to be an acute angle because this side is smaller than that side. Since this is the biggest angle, no other angle could be obtuse. I plug this in my calculator, and that should be only the acute angle, only in quadrant 1. And I get, when I plug this in my calculator, I get this to be 45.03 degrees, and automatically I know how to find the last angle. .03 degrees, and I know how to find this. That's 180 minus. If I take 180 minus 45.03 minus 51.1, I'll get this to be 83.87 degrees. And that's pretty much how it works. So if I can't use the law of sine, I could use the law of cosine to find one of the angles or the sides, if that's the case. And in those two problems, we have them set up the same way. If I look at this problem, again, the same deal. I'm having an issue with this because I don't know side C. So I can't have two unknowns. I can't say the sine of 108 to C equal the sine of 8 to 22. That's two unknowns in one equation. So I'll use the law of cosine to figure out what C is, and C would equal, C squared would equal 30 squared plus 22 squared minus 2 times 30 times 22, the cosine of 108 degrees. So once I get that, I know C will equal the square root of that value. And if I plug this in my calculator, 30 squared plus, let me see, I get C to be 42.33. And once I get that, again, I could use the law of cosine, but it's a bit longer to write, that is. Once I get this, I could say, well, alright, now that I have this, let's go by the sine of 108 degrees to 42.3 equal, let's say, the sine of beta over 30. And if I cross multiply, I know that the sine of beta is going to equal 30, the sine of 108 degrees divided by 42.3, and beta would be, and I plug this in the calculator, and I get this to be 42.4 degrees. And if I know this is 42.4 degrees, I could figure out what this angle is by taking 180 minus 108 minus 42.4, and that would be 29.6 degrees. Now if I move to the next problem, I noticed they didn't give me any angles in this problem. So what I would do, I would actually figure out an angle. Now, since I'm using the law of cosine and I'm not looking for the two cases, it doesn't matter which angle I find. So I could say, let's find angle C. If you want angle C, what do we know? We know that 65 squared, according to the law of cosine, again, law of sine doesn't work. I know that 65 squared equals 50 squared plus 72 squared minus 2 times 50 times 72, the cosine of angle C. If I swap those, then I'll get 2 times 50 times 72, the cosine of C, equal 50 squared. Of course, I could evaluate those on my calculator, but if I divide both sides by this, I'll get the cosine of C to equal 50 squared plus 72 squared minus 65 squared divided by 2 times 50 times 72, and C will be the inverse cosine, and I don't have to worry about the two cases because cosine is positive or negative, makes no difference. There's only one answer. So when I get this to be 0.48, my answer, the angle, will be 61.283 degrees. The reason I wouldn't say or, because cosine is positive in quadrants 1 and 4. There's no way you could have an angle that's bigger than 180. So the law of cosine doesn't have that issue. Once I figure out that this is 61.3 degrees, if I want to use the law of sine, I suggest you find angle B. Because if you find A, which is the biggest, you could have that issue. So I'll go play it safe and say the sine of B to 50 equal the sine of 61.3 degrees to 65. And the reason this is safe, since 50 is smaller than 65, this angle has to be smaller than 61.3. It can be the two cases. So I try to avoid the two cases all the time. So here I know the sine of beta will equal, so I get this to be 0.67, and the angle will be 42.4 degrees. And to find this angle, I will take 180 minus 61.3 minus 42.4, that's 76.3 degrees. And that's pretty much how it works. Now it's going to be your choice to use law of sine or cosine. I'm going to specify. Solve the following triangle. If you're going to draw this triangle, again, you don't have to draw it to scale, but let's say this is 23. 28 is a bit longer. So let's say this is 25. And this is 28. So this is 28. This is 23. Or this is 25. And this is 23. If I'm being a bit picky. Well, this is angle A, this is angle B, and this is angle C. And again, the same problem. I could force you to use the law of cosine because here you have no choice. And if I'm going to use the law of cosine, let's say I'm going to find angle C. Of course, you could find angle B because the law of cosine doesn't have the two cases. And I could say, if I want to find B, for example, I could say 28 squared equals 25 squared plus 23 squared minus 2 times 25 times 23, the cosine of the angle opposite of 28, which is B. And again, I could swap those. Of course, you could simplify that beforehand, so you don't have to carry all of this mess, but I want to keep this so you could see it. And I could divide both sides by this and get the cosine of beta to equal 25 squared plus 23 squared minus 28 squared divided by 2 times 25 times 23. And I can get beta And let me get that out of the way. And I get this to be 0.32, and this is 71.2 degrees. And once I get that, again, we could use the law of sine. That's not a problem. That's shorter than this. I could say the sine of 71.2 degrees divided by 28 equal, let's say you want to find C, the sine of C divided by 25. So sine of C equals 25, the sine of 71.2 degrees divided by 28. And I could say C equal the inverse sine. Let me work that out. And I get this to be 57.7 degrees. And I know the drill. This right here would be 180 minus 71.2 degrees minus 57.7 degrees. And that turns out to be 51.1 degrees. Okay, I'm going to stop this video here and continue in another video.